So the first thing is that there are some really cool stickers if you would like to show support for UMA. There's, I don't know, 7 left. So, just go ahead, take one. But during this session, what I would really like to do is to go into some technical details. And I think that it just might be valuable to sort of do that by going back and forth into the spec as well and showing some specific parts, but explaining that. So I have both slides and the specs. And the objectives are to sort of show you that there are basically 3 core specifications that make UMA as it is right now. It's the core specification, as we call it. It's basically called the UMA User Managed Access Profile for OAuth. And the second spec is in relation to resource registration, so the OAuth resource registration. And the third one, which is sort of new, but it's for one of the flows that is within UMA, and it's for enhancing the security of one of the endpoints. The third one will be sort of, it says it's not covered, but we'll cover that to some extent. Yeah, and we'll walk through the spec. So just to tell you regarding the specs that are worth looking at prior to working with UMA, it's obviously the entire set of specifications related to OAuth, but most importantly, the framework itself, the dynamic client registration, but also the token introspection. OpenID Connect, it's not specifically needed, but it's used in a number of flows. And in user managed access, we have, as I mentioned, 2 different specifications, 2 different versions, 1.0, which was released in April, and 1.0.1, which was released at the very last day, I think, of December. And yeah, this UMA claims gathering extension for enhanced security. So let's go, sure. Oh yeah, sorry. So that's basically the December and the April version. So there are some differences. Yeah. So I'm not sure if it actually has a. I'll show that. Maybe actually increase this one. Yeah, I didn't not include the version, but it's version 1.0.1. That's the newest version. So right, so we'll go now through that specification, so for the core specification, which you can access directly from the UMA website. If you search for UMA Kantara, then you can go to the website of the workgroup, and in here you can take a look at the links to the specifications. So there's 1.0.1 recommendation and the OAuth resource set registration recommendation. So these are these 2 specs. So let's go through the first one. So very briefly, the spec describes all the processes, which are quite simple. Just protect the resource, the client then gets the authorization and accesses a resource. But there are a lot of various details that have to be taken into account, and we'll talk about that. These phases are visualized on this diagram taken directly from the spec. So the resource owner manages resources at the resource server, and that's phase 1. You protect the resource. Phase 2 is between the client and the resource server, and that gets authorization and access the resource. So protecting the resource is in that part of the architecture. So it's all about this protection API token, the way it's obtained, the way it's used. The get authorization is about this part. It's about the authorization API token and how the client uses that at the authorization server. And getting access, it's actually quite a big section in the spec. It's because the client has to be able to get the RPT, requesting party token, use it at the resource server, and it may also use the AAT to negotiate access at the authorization server. We'll talk about that. And the protection API token itself, it's also used in that process because it's used for checking whether the RPT is good enough. And importantly, the specification itself only defines the messaging protocol. So that's why when I said about how the policies are set, etc., that's outside. But also, it's very important, is that the technical contract is defined within the specification. So you can see that the work group also works on these recommendations for agreements about the rights and responsibilities of different parties which operate as part of the UMA architecture, and that's on the contractual and legal level. We'll go just through the terminology, but this was already covered in the first section, in the first part. But the resource owner, it's an OAuth resource owner, so it's someone who manages a resource. It can be a person, but it can be a corporation. Policy, something which is used in the spec. That's how access is either granted or denied. The requesting party, this is also an end user, which is a legal entity or a person that uses a client, another software, to seek access to a protected resource. The client is the actual software that tries to access a resource. A claim is a statement that has some value or a set of values that are provided to, on behalf of a requesting party, to the authorization server. The authorization server uses those claims in the policy decision-making process. And the resource set, again, it's one or more protected resources. So it's up to the resource server how they define a specific resource set, which is treated in the access control as an object on which access, is being done.
In the terminology here for the client, it's described as basically being a delegate or doing something on the requesting party's behalf. Have there been examples where a similar component would exist for the resource owner, that they would have some type of component that does things on their behalf, so maybe to respond to certain events?
The response what? Sorry. Right. The only thing is when you're thinking delegate something or someone that would, for example, manage the access for a resource or manage, is that what you're thinking of, or?
More on an application side. So you have this recognition of an application called a client that does things on behalf of the requesting party. Does a similar thing exist, or could one exist for the resource owner?
Yes, but in the case that it would still be a client, when the requesting party would be the resource owner, I guess. So you could connect possibly a client to act on your behalf to the resource server, but you would be both the resource owner and the requesting party. It's just that UMA clearly states the requesting party as a different entity, as a different term, but it can be the same entity. Does that make sense?
Yeah, just trying to play things on my mind as we
Sure.
talk more about Internet of Things and
Yeah.
kind of automation, how that might play into it.
Okay. Are there any other questions so far? Right, so next it's a scope. When the resource server registers a resource set, then they also provide information about the possible actions on that resource set. So, like read, manage, but if it's a picture, maybe resize or anything like that. Requesting party token, that's, as I mentioned, an UMA token. Specifically UMA, it's not an OAuth token that has some permissions associated and allows the client to gain access to a protected resource. The authorization data, this is the data that is associated with the RPT token. The authorization server, obviously the central component that makes access decisions. And the permission, that's something which is a concept that's used by the resource server. So if I try to get access to a resource, then the resource server tries to define a permission which would at least encompass or include this specific access request and register that permission at the authorization server. So if my client then would like to get access to a resource, then they have to be granted the specific permission. And the permission ticket is basically this correlation handle. So it refers to that permission registered by the resource server at the authorization server. Authorization API token, that's a token which is used by the client at the AS. And the RPT endpoint, that's an endpoint which is used to issue RPT tokens for the client. And the protection API token, that's a token that the RS uses in order to register permissions, register resources, but also introspect tokens, RPT tokens. Again, we have a number of endpoints. So these endpoints are a part of the protection API. So that's a resource set registration endpoint, the permission registration endpoint, and the token introspection endpoint. They were discussed earlier. So allowing to register resources, register permissions, and see what permissions are, what authorization data is within a token. Yeah, and yeah, that's basically that. And importantly, two things about TLS and HTTP. So the first thing is that the resource server has to have an interface, and there was one question about that. There has to be an interface which is HTTP based, so the API is an HTTP API. And the other thing is that, access to the API is, so the communication is actually secured with TLS. So these are requirements which are clearly stated in the spec. OAuth 2. Yes, by the way, why did we abandon the OAuth 2 naming in the spec in favor of OAuth? I think OAuth 2 is just referred in the first set of sentences, and then we just talk about OAuth, but it's all OAuth 2.
Yeah, we linked to the OAuth 2 spec.
Yes.
In the committed references.
Yeah.
To say OAuth. I think it expands to OAuth 2 every time you refer to it.
Yeah, so maybe some of these are not copied, but paraphrased from the spec. That's why it might have been omitted. Yes?
You might talk about this slide.
This one?
Yeah, the permission registration endpoint. Would you mind explaining that a little bit further?
Yes. So, but this will be discussed further. But in short, in UMA, if a client seeks access to a resource, so executes an HTTP request to a resource, and this request for whatever reason either does not include an RPT or has an RPT which is expired, or an RPT which does not have the specific set of authorization data for that request to succeed, what the resource server does is that it goes and registers a permission and gets back a permission ticket, a value which it gives back to the client so that the client can go to the authorization server and do something, negotiate access, in order to get an RPT which would be sufficient for that access request at the resource server to succeed. This will be this.
Like an example you demonstrated earlier, the request.
Yeah. Well, no, not necessarily. It's it even would include the first example. It's more of a technical. I'll explain that further once we get into details. There will be a specific example of the request and response, etc. So, yes.
One more question. So, in the scope of this discussion, is the authorization server that's used by client and resource server are the same?
Yes, because you try to access a resource, and this resource is protected by this AS. So there's the AS has a policy for that resource. So the client has to go to this specific authorization server, negotiate access in accordance with the policy. So yes, it's the same. Right, so again, Protection API consists of these three endpoints: resource set registration, permission registration, token introspection. And, all right. Sorry. And in order to be able to interact with that API, so in order to be treated as a resource server, you have to have the Protection API token, which means that this token has the UMA protection scope. That's what we define in the specification. So this token also binds the resource owner, because you establish as a resource owner the relationship between the resource server and the authorization server, and obviously the RS and IS. And very importantly, the API that the resource server it has to be structured in a specific way. So UMA does not or may not be applicable to all APIs that exist. So whenever a request comes and the resource server receives a request from a client, it has to be able to determine specifically which resource is being accessed. So it's not without any additional information. So it doesn't, if the access request is without any token, the resource server still has to be able to know that this resource set, which is being accessed, is for user X, for user Alice. And that's why it has to be able to get the permission API token for that user. It has to know which authorization server is responsible for that resource. But the information about the API, or sorry, the information that allows the API to be uniquely identifiable, it can be within a URI, or within headers, or even within the body of a request. But it has to work like that. So these are actually both good examples, but of good example of bad API or a good API. Yeah.
If the request, the initial request, for example, doesn't have an object, are you still saying that the API has to indicate the resource server who the authorization service is, or is that the
Yes. Well,
configuration?
no. So that's if there is a request that comes to there's no RPT. The resource server, yes, it has to be able to understand where which authorization server protects this specific resource.
There's one use case where you never have to guess which resource owner it is, which is when the enterprise of record
Yeah.
is the only resource owner possible. Like that's your use case, I guess. So then you don't need it indicated in the request.
But in the case of Tom connecting to this resource server, for example, how could any context about authorization service being passed on that initial call? Shouldn't that be the binding or the configuration that already existing resource server about that resource and the corresponding authorization service?
No, but the configuration is at the resource server side. It's that I think it's clearly shows it here. Like you just have to have the information in the request, in the URI, or in the body or in headers, that would allow the resource server to understand who's responsible for that resource on my side. So the resource server can make a decision. Okay, I need to actually go and register the permission at this specific authorization server.
So that the client has to have that information and pass it on.
No, the client does not have to. It gets that information from the resource server.
It's a question of API design, so the client would learn of the design of the API from the RS, the API documentation, essentially. So think about the Twitter API, for example. It only knows about what users being and it asks for the user it wants essentially, because the user comes with that whole flow. But UMA has more like a web access management flow, if you will, because the client hits the resource first, and that's by virtue of the requesting party knowing what they're looking for. So because of that difference, client to RS first is how we think of it. The intended resource has to belong to somebody, and the RS has to know who that somebody is in order to convey to the AS what's needed. Does that make sense?
Right, and so, and actually, interestingly, the statement that the resources have to be uniquely identifiable, it's mentioned, I think, at least 5 times within the spec. So, yeah, but nevertheless, the access to a resource at the resource server, it's important to note, it cannot happen without an RPT. So eventually, there will need to be an RPT in the access request. Okay, so we covered the authorization API, the protection API, and the authorization API. So there's just a single endpoint. In the previous version, we had 2 endpoints. Now we merged them together. There's just the RPT endpoint, which is defined in the core spec. So by the way, the previous endpoints, the protection API endpoints, there's only one endpoint defined in the core specification, which is the permission registration endpoint. The token introspection is covered by the OAuth 2 token introspection specification, but it's amended. And the resource set registration, it's also covered by the OAuth 2 resource set registration specification. So what makes an authorization API token? It's a token that has the UMA authorization scope. And it binds the requesting party, because the requesting party connects or establishes this trust relationship between the client and the authorization server. Obviously, the client, the AS, but it's not specific to a resource server or a resource owner. Right. And the requesting party token, that's used by clients to access resources, and it binds the requesting party. The client, it is actually specific to the resource server, so you do not share the same, by default, you do not share the same RPT across a number of different resource servers and the AS. And the way time to live is managed is that for most importantly for the RPT, this can be managed through policies. So you could, for example, say that a particular access is only given for the next 24 hours or for the next hour. But obviously the OAuth tokens, standard rules apply, and for client credentials the same. Okay, and the relationships in UMA are by default dynamic, which means that if I would like this resource server to use my specific authorization server, and there can be no prior relationship between these two, then there's some form of discovery. So what happens is that the RS can discover information about the authorization server by looking at the UMA configuration directory in the host meta location. And this is we won't go through all the things, but this is what the standard configuration looks like. It includes information about the issuer, so the authorization server itself, the profiles which are supported for each token that we discussed, the grant types for the OAuth tokens, but also the location of endpoints, specific endpoints, so that the resource server or the client can discover these endpoints and interact in a dynamic way. One important aspect, and it won't be covered during today's presentation is actually the dynamic client endpoint. So the resource server or the client, they can actually register at the authorization server. They can obtain the client credentials, the OAuth client credentials dynamically. So there's really no need for any form of trust relationship between these two, prior trust relationship. Okay, so we talked about 3 phases: protect the resource, get authorization, and access a resource. So protecting a resource is that prior to that happening, and that's why I said we won't be covering this dynamic registration, is that the RS has the credentials already. So it is able to act as an OAuth client to the AS. They can be handed out, they can be provisioned out of band or statically or dynamically. But also, the RS acquires the path from the protection API token from the authorization server. And once these 2 things are met, so the resource server is in the possession of a protection API token, in an ongoing fashion, it registers resources. So if I go to my personal data service and I create yet another entry, I can select for that resource to be protected. And the way the resource gets registered at the authorization server is through that resource set registration protocol, which we have in the next spec that I'll discuss. But once the resource is registered, so once I decide as an owner or as the owner of the resource that it should be UMA protected, then really the RS must limit access to that specific resource according to whatever the AS authorization server says.
We did soften that with the Adrian clause, in fairness.
Right. Okay, so.
Should I describe the Adrian clause?
Yeah, so I don't think I have that actually in the spec. But if do you want to, because you just mentioned that to one colleague, maybe you would like to cover that in more details, or at least mention what the clause is.
So it's nicknamed the Adrian clause. Where the camera is, so just over here. The Adrian clause is nicknamed after Adrian Cropper, who's one of our number. And it's a clause that basically says that the resource server has the right to apply additional authorization processes at the edge, and essentially to tighten authorization controls if it needs to. And that's because the reality is, just like in identity land, in federation, the relying party always has the right to refuse service. So does the resource server. And there's a subgroup in UMA called UMA Legal, where we're developing model clauses to help enforce elements that are not technically enforceable. So, in fact, I think we took away that must. So we can double check that, but we have this clause. Yeah, Harvey.
So what is the effect then if you soften it yet? I'm sure you have sufficient controls. Just help me understand a little bit there.
Well, so what we've got is we've got a loosely coupled system where, unlike in OAuth, where in practical terms, base OAuth, where in practical terms the AS and the RS are kind of assumed to be in the same domain, even though they never say so. We're explicitly making it possible for them to be run by different organizations. They're in different domains. And we're trying to turn the screws to make it as enforceable as possible to have the RS do what the AS says. And in practical terms, you're standing up. It's OAuth protection just the same way all OAuth protection is. And the implementation choices for an RS run the same way that you find them all over the place. Gateway, client library, all those sorts of things. So in practice, it's going to work the same way. But in reality, for business reasons, you're changing the relationship somewhat. We're giving Alice, the resource owner, the power and the deliberate choice to effectively uncheck scopes, whereas that's a less often seen choice in plain OAuth. That's the point of UMA, or it's one of the points of UMA. So.
Sure.
Could it only make it more restrictive, or it has that flexibility to make it looser or
don't let it in and you do want to, now there's a question. And now it becomes a question of, well, what did you contract with Alice to do? And do you have a formal means of notification if there's an exception? So there's in-band and there's out-of-band exceptions. I think that's the shortest description I've ever given of it. Let me sit down and take it over now.
Okay, so thanks, Eve, for that. So phase two. So phase one, actually protecting a resource, will be covered primarily on the second spec because, yeah, it's not within UMA core. But getting authorization, so the second phase of the protocol, that's really interesting. So we talked about clients attempting to access a protected resource, and there can be a number of cases. So no RPT, which is the basic one, right? We just hit an API. Or there's an invalid RPT, we just included maybe the wrong token or it's already expired. Or there's insufficient authorization data. So we previously had some interaction with that RS, so we were already accessing some resources. And there's a new resource that we try to access. And at that point, yeah, still no authorization, which was sufficient, authorization data sufficient for that access would be associated with the RPT. So in either of these cases, what happens is that the RS registers a permission with the AS that should be responsible for that resource. Is actually responsible for that resource. And I'll show how the registration looks like in a second, but in short, it actually does result in what we call a permission ticket being generated by the AS and returned back to the client, to the resource server. And there's only one case that it can fail for whatever reason. We just get some information back where we would pass that information back to the client as a warning. But other than that, the ticket gets passed back to the client itself. And once the client is in a possession of this permission ticket, then they can request the authorization data from the AS. And the AS simply returns an RPT with the data associated. Obviously, there's this negotiation phase, but we will go into details in a sec. So let's take a look about specific examples. So we try to get access to a resource. We execute a GET request. There's no RPT. Or we just include an RPT, but it's invalid or insufficient, or it has insufficient authorization data. So the RS registers a permission with the relevant AS. So it checks who is the owner of that resource, where this resource got registered. It takes the protection API token, and it registers a permission. And the permission has to be it has to at least include the original access request. So that if I asked for getting access to a photo, then it's a read type access, and the permission that would be registered at the AS should include that, but the RS can also include all kinds of different permissions that it thinks might be relevant. So for example, I will also allow for accessing, for having a write access if it's a more trusted client. It basically decides on its own. And the path, so the protection API token that's included in the request during permission registration allows the AS to map the permission to the specific resource owner. And the AS returns the permission ticket to the RS. Let's take a look at the example, which I think actually we have an error in the specification, I guess. But what happens in here is that what we do is that we register the resource set which is being accessed. So the RS gets that information from the context of the access request, and the scopes for which authorization should be granted to the client. And yeah, and this can, as I mentioned, this can include the original request. Actually, I need to check in the spec if we really have an error or if I copied that incorrectly. I'm pretty sure we actually have an error. Yes, okay. Okay. So this shouldn't be a resource set registration endpoint, but yeah, we'll change that. Nevertheless, yes, that's just an example, but it would be good if it was clear. But nevertheless, so the resource server registered, some information, and this permission ticket got created. And as I mentioned, it is used for maintaining this state of what the RS register at the AS and what the client will be trying to get. And it should be short-lived because it should be immediately returned to the client, and the client should go to the AS and try to get the necessary authorization data. And it is opaque, basically, to RS and the client itself. And in the core specification, we do require that the ticket is securely random, so it cannot be guessed by any of the parties. But I'll talk about the enhancement that we did, which actually relaxes or changes this requirement. Importantly, when the permission ticket gets returned to the client and the client then interacts, then it already interacts with the AS to get the authorization data associated with the RPT. This permission ticket should be already linked with this specific requesting party that first made the request, because we just sort of treat it maybe similarly to the code in OAuth. But if the same permission ticket is used by different clients, that it can be considered compromised, and all the requesting party tokens should be revoked based on that permission ticket. Right, but they must not be single use. It's really important that UMA has this concept of negotiating access, and it can involve a number of trips between the client and the AS by allowing the client to submit necessary information to the AS in order to win access to a resource. And the same permission ticket is used. But once the RPT is granted, then it should be invalidated. And so the RS registered, finally, the permission, and it gets back the ticket or some error response. If, for example, there was an invalid resource set in the request or an invalid scope, maybe not relevant for that resource set. But this specific ticket is passed back to the client. So you can see that what the client gets is, for example, a 401 response, which says that you won't get access to that resource, but it is UMA protected. So we include the UMA as the authentication mechanism in the authenticate header. We provide a location of the AS which is responsible for that resource. And we also include the ticket. In the older specification, we would return the ticket in the body of the response, but in the new specification, we basically consider that as a deprecated response. But we still allow it. If for whatever reason the permission registration was invalid, then we actually communicate that back to the client. Yes?
Is there an effect to the deprecated response? Or what
No, it's
are taken from that? Or?
it's just that maybe some implementations have been based on UMA 1.0, and there are some clients which do expect the ticket to be returned in the body. However, if the RPT was sufficient, so if the client was actually accessing and none of that happened, so the permission registration was not happening, we just got the representation of the resource. So how does the RS knows if it should register a permission or not? So it basically, if there's no RPT, that's obvious. But if there's RPT, what it does is that it tries to, or it checks its status. It does that either locally or using remote token introspection at the AS. And what we do is that we profile the OAuth2 token introspection endpoint. So we extend it a bit. And that's the response. It differs in the sense that we don't define scopes in here, but we have permissions. So if the RS submits an RPT, what it gets is that it gets an array of permissions, and each permission includes a resource set for which this RPT is valid for. Sorry for that, and the scopes and the expiration. It can also include if it should not be used before a particular time. Right. Okay, and in a situation where the client has obtained a permission ticket and AS location, we'll now go into details about this negotiation phase. So the client, if it does not know the AS, if it hasn't had any prior relationship, it does the discovery process, and it obtains the credentials, either dynamically, or if it knew the AS, maybe it already has the credentials for that. But interestingly, it also, in UMA, apart from standard information, OAuth-related information, it also should register the claims redirect URI. That's the URI that is used in one of the flows, which will be shown later. But before the authorization can be sought, the client has to have the AAT. Okay, so the client got the ticket. Okay, go on.
So in the previous slide, does client have to validate that this AS is the same as RS?
Well, the client gets the location of the AS from the RS.
Yeah, but this location can be forged.
Well, but it wouldn't can get access to that specific resource.
Yeah, what if I just forge this location and send to my own malicious AS client?
So, I mean, there is a danger for the location to be forged and returned to the client, and the client then has the potential danger of submitting the information which would be used for the policy decision-making process to the wrong AS. Yes, that's true. So, yes, for example, yes, that's one of the approaches. Right, but once the client gets sorry for that. Once the client gets the ticket, and for example, if it already had an RPT, what it does is that it goes to the RPT endpoint and provides the ticket, basically makes a post request with the ticket, possibly including the already existing RPT. And that's where the flow starts. So the authorization assessment process itself is outside of the scope. So, the policy, how it's assessed, what kind of policies there are. It can be XACML policies, or it can be some proprietary language. That's something which is out of scope. But importantly, the client may not really need to satisfy the entire policy. So we do allow the partial fulfillment of what the policy says. but the AES itself must use a default deny authorization assessment model. So what is the response on this request for I want to get access? So, it can be an invalid ticket, so something which, does not exist, or expired, something which, expires simply. Or the client is definitely not authorized to access the resource. So the AES decides that it will not engage in any process. And the two important ones and really interesting ones are the need info and request submitted. So the need info is a response which is sent by the AES back to the client, and it basically tells the client one of three things, or actually it can even include all three things at the same time. The first thing is the authentication context. So it may the client may be told by the AES that the AAT that it used to communicate with that AES is not strong enough. So, for example, it's been minted when the requesting party authenticated just with username and password, and you should re-authenticate with two-factor authentication. Or it can also mention the required information which has to be submitted by the client for the authorization, for the policy decision-making process. And this can be in two different forms. So we can either ask, we cover the user is redirected to the AES for authentication, or the client can push information directly to the AES, or the client will redirect the requesting party to the AES. Like in point 2, we just provide information which the AES uses. In point 3, maybe the client is claims unaware. They are unable to send the required information, or there's some additional process that the AES is looking to engage the requesting party in. Of course.
The only difference between 1 and 3 is the kind of information that's missing.
No. Sure. So the question was if 1 and 3 is different just from the perspective of missing information, as I understand, right? So just for 1, the problem with that the AES would like to solve is that the AAT that was used to get the authorization data associated with an RPT. So Mike can tell more about that, as he's the inventor sort of this, but in short, the AAT is not strong enough. And in 3, there's nothing wrong with the AAT. It's just that we would like the client to be at the AES, the requesting party to be at the AES and provide information directly to the AES, whatever information that is. It can be, even just solving a CAPTCHA, for example. Yes? Yes, that is definitely possible. So let me just go through. So it is basically possible to split that process into phases. But let me maybe take a look at. Discuss these. We actually are quite short on time, or even very short on time. But what I'll do is that. All right, I'll give you the example of this redirection, for example, for the requesting party. So what can happen is that if there is some additional process that's needed from the resource owner, then what the client gets in return is that okay, I tried, I submitted a request, but then I need to wait for the resource owner to appear. For example, one of the use cases that we had is that there's just a notification on the phone, and it requires the resource owner to simply accept and or maybe extend the the set of permissions that would be the set of the authorization data that would be associated with the RPT, yes, this can happen outside of UMA. So the way that the resource owner interacts with the AS is totally outside of the protocol. So once the policy gets created in whatever way, by confirming something, for example, then if the client repeats the process, then it would get finally the authorization data associated.
So when you repeat the process, do you have to resubmit the permission token, or is that already remembered?
No, you do have to resubmit that.
So then I guess
Requesting party token.
right. But I guess then the assumption that it's always a short-lived ticket, it's not necessarily that.
Okay, the requesting party token, but the permission ticket, well, you would need to get a new one, yes. The only thing is that the permission, so the policy, it's not created for the permission ticket, it's for a resource. So because I have, if I try to access a picture, right, and there was a notification created at the AS which would allow the resource owner to go and confirm that access to that picture should be granted. And then the client tries to go and access that picture again. It still provides an invalid RPT to the RS. The RS registers yet another permission. But in this case, if the client takes that permission ticket and goes to the AS, the permission ticket specifically links to a resource set, and the policy is already created, which means that authorization data is associated with an RPT, returned back to the client, and then the client uses that. So yes, there's a new permission ticket, but the same requesting party token. I'm not sure if that's clear, but. Right, and some information about UMA errors. Are there any more questions? Because I'll try to still go through some slides, and I think we'll have a break. So UMA errors, just standard OAuth errors plus UMA error responses, mostly from AS and RS. And actually, we didn't go through the resource set registration, but it's really simple. It's just a CRUD API, CRUD type API, where a resource set and a scope gets registered. Sorry, a resource set gets registered. Actually, scopes not. Scopes are just referenced. And that's a resource set description. So there was a question. So there's a name, there's an icon, the scopes, and the type. And the scope itself, it has a name and an icon as well. Icon URI provided. And importantly, scopes can be either URIs or they can be, plain strings. And the CRUD API, which allows the RS to, register resources for protection, is very, very simple. So there's an endpoint, and we can create a resource set, so register. We can get the information back. We can update, for example, if we extended some, if we added new verbs to a particular resource, so new actions. We may want to deregister that, so delete it, and just list all the registered ones. There's an example of a create request, and there's a response. And importantly, the response contains this AS-generated identifier and a very handy thing, which is a location of a policy. And that's for UI reasons. So you can then take that URI as a resource server and allow the user to maybe click at the resource server on a share button and bring a pop-up with the policy for that resource. And just the security extension, For the claims gathering process, there was an identified session fixation attack, but this was for one of the specific flows, and the extension changes some OMA requirements. So the permission tickets, and these requirements are that the permission tickets may be single use. Sorry, actually must be single use, to be fair, in this extension, and it cannot be. I'm sorry, it cannot be the same value that's provided back. So it gets regenerated. So the permission ticket basically becomes a single-use nonce. Okay.